out at 180.
Right, so if you take twice 72, you get 144, you need to add 36 to make 180, right?
Yeah.
So now if I bisect this side, what happens? Well, sorry, if I bisect that angle, then I get two 36-degree angles. And what does that mean about the two new triangles? So if I have triangle, the original triangle is ABC. Then what can I say? Let's call this point P.
108, 60, 72.
So what can I say about A? So AC is equal to 1, right? So what's AD? Well, I'm saying that's also 1. How do I know?
It doesn't. So
Because it's still.
This is going to be 72 also, right? 36, 72. That means that has to be 72.
No. No. Because the next six that's 72.
quick question on the circle on the right. Doesn't Pythagorean theorem just specifically say that that would be like c squared? So doesn't that have to be 1 still? What am I missing there?
There's no right triangle?
So it requires the right triangle.
Yeah, to use the
Okay.
Pythagorean theorem, you need to have the right triangle.
Gotcha. In this case, like sine of 72 over x, you want to do it without sine, right? Because that would be
Yeah, we don't
equivalent.
know sine yet.
Okay.
So we're just working on the geometry here. So, so these two sides are equal, right? What about BD? Well, triangle ADB is also isosceles, right? Because these are both 36, 36 and 36.
Mm-hmm.
And what do we know about the sides of an isosceles triangle?
It's AD and BD are the same there.
Yeah, so this is also BD. So that's also 1. So what does that mean DC is?
It means that DC is,
Like this whole side here is X, right?
yes.
So what's this little piece here?
X minus 1?
Yeah, take 1 away from X and you got what's left over, X minus 1. Okay, so what do we know about triangles ABC and BCA?
A, B, C, B, C.
Oh, sorry, it's the same triangle.
Yeah.
I meant to say ADC.
The scaling factor?
Yeah, so there's a scaling factor. In other words, what else can you say?
It's double the size. ABC is double the size of ADC.
Well, not double.
One third.
Yeah, we know that they're proportional. And what does that mean? How do you know they're proportional?
It's because 2 points of them are touching, correct?
Well, that's not sufficient. They're equiangular, right? They have the same interior angles. The small one is 36 degrees and the two big ones are 72, right?
Yes.
So, when two triangles are equiangular, what do we say? Well, they're proportional, that's true, but there's another word for that which is similar, right? And so these are similar triangles, right? They're different size but same shape, right? And what do we know about similar triangles? Well, their corresponding sides are proportional, right? And so what proportion can I write? Well, I can say base to side. So the base of the big one is 1, and the side of the big one is x. So for the little one, the base is x minus 1, and the side is 1, right? So there's my proportion. And what does that allow me to do? I can now solve for x, right? This is an equation. What kind of equation is this? Quadratic, right? Yeah. And so, you know, you could, you know, anytime you have a proportion, you could say the product of the means is the product of the extremes. And so, 1 is equal to x times x minus 1. X squared minus x is equal to 1. So I add a quarter to both sides to complete the square. And you've got the square of x minus a half is equal to 5 quarters, which means that x minus a half is, well, we want it to be positive, right? X is bigger than a half, right? Oh, I'm sorry, x is, yeah, bigger than a half. How do we know x is bigger than a half? Well, it's bigger than 1, right? 1 is the short side, x is the bigger side. So it's got to be the square root of 5, the positive square root of 5 over 2, which means it's 1 plus square root of 5 over 2, which is approximately, as everybody knows, 1.618. Does everybody know that? Why do I know it? Yeah. This actually has a special name. It's sometimes called phi, or the golden ratio, the golden mean. It's a very special number, and it's considered to form a pleasing proportion. So, yeah. So, what does that have to do with the pentagon? Well, it's got these same angles, and I could bring it to bear somehow on the pentagon. But so if I want to draw a pentagon with GeoGebra, and we'll take a break here pretty soon. What do I do? Well, I get a new window. And, I have to get rid of the. What do I want to do? Get rid of that and make it another graphics window. Now I've got the axis to get rid of again. All right. This one, right? Show axes. No, don't show axes. Thank you. So now if I draw a point and I make a circle centered at that point with point at about 3 o'clock, and I draw the radius like so, how do I get the next point? Well, I'm going to want to rotate this thing by 7